Our aim for today, Kipsters will be able to find the slope of a line using slope formula. So this is going to be useful when we aren't given points on a coordinate grid. When we are either just given like, hey, these are the coordinates of 2 points, or when we're given points that are not on a coordinate grid. When we're talking about slope, we're talking about rise over run. So we're talking about 2 points here. Each point, we'll call this point number 1. We'll call this point number 2. Each point has an x and a y. Okay, each point has an x and a y. When we're thinking about rise over run, rise is talking about how much you're changing in which direction, x or y. Which measures up and down? Which measures our rise, y's or x's? Psalm? Y's. So rise is really just talking about the change in y. So that means the run must be talking about our change in x. So sometimes mathematicians will commonly write this as delta y, because remember that word or that symbol delta means change in y over change in x. Now, if I want to find out how much something changes, what do I normally do? If you have $150 one week and $225 the next week, and I say, how much did the amount of money you have change? What are you going to do mathematically? Christopher? Yeah, you're going to subtract. So when we're talking about doing this, we're going to be talking about subtracting our y's. That's what, when we want to find the change in something, we're talking about subtracting those things. So if I want change in y, I want y1 minus y2. So if I want to know how much we changed in x, how much we ran, how can I figure that out mathematically? Solve. Louder.
Y minus y?
That would be our change in rise.
Oh.
Because y's
X
are
minus x.
x1 minus x2. Now there's one thing that we really have to make sure of here. We're going to get our positives and negatives mixed up if we don't have both of our y's, or both of our 1's on one side and both of our 2's on the other side. It actually doesn't matter if you flip-flop them. That's why it doesn't matter which point you label as point 1 and which one you label as point 2. But it's super important that both of your things from point 1 are on the left-hand side. Both of your things are from the right-hand side. Cassandra.
I mean, the y1 minus y2, why can't it be squared instead?
Because we're not talking about exponents here. We're talking about these are values of points. So these little things down here, these are subscripts. These are just to give more information about what that value is, what that variable means. Okay? That's what subscripts are for. They're not mathematical. That could have been y sub a and x sub b. Just gives more description. So we're just saying this is the y from point 1 and the y from point 2. That's a really good question. So the reason why I go through that with you, rather than just giving you the equation and saying, hey, this is the equation, memorize it, is because 50% or more of you in this room are not very good memorizers. I am not a very good memorizer. When I was your age, I would not have even attempted to memorize this equation. This is exactly how I would have done it. The thing I would have memorized at this point was that slope equals rise over run. Then I would have thought to myself, okay, my rise. That's really talking about how much I'm changing in my y's. If I want change in y's, I need to subtract my y's. Run, talking about my change in x's. So if I want to find out my change in x's, I need to subtract my x's. So really, this process and this entire thing, no, I'm not going to ask you to write that down every time. However, that's really your key to remembering and being able to use the slope formula. Some of you, yeah, you're going to be able to memorize it. You're going to look at it and you're just going to remember it. Most of us will have some trouble memorizing it, so we need some things like this and some reminders of where it comes from to help jog our memory as to what that was, okay? So, looking at this, this is our first example. We've got these 2 points. There's not a coordinate grid, so I can't use a slope triangle to count my rise and my run. So I need to remember that slope is equal to rise over run. And that will remind me once again that I'm talking about my y1 minus my y2, because y's are measures of how far we are up and down, our rise. And our run is our x1 minus our x2. Now, all we got to do is figure out what y1, y2, x1, and x2 are. Then we plug it in and solve. Super easy. What we're going to do is we're just going to label each point. I'm going to go ahead and call this point 1. And I'm going to call this one point 2. It doesn't matter which one you call point 1 and which one you call point 2. Either way, you're going to get the same answer. Now, one thing we should know looking at this line, when I get my answer to my slope, that slope should be positive or negative?
Positive. Negative.
Positive or negative?
Negative.
Negative, it's going down. So when I get this answer, we know it's going to be negative, and that's one thing that we're writing down. Which is really nice when they give us points like that, we can help figure that out. All right. Now that we've labeled them point 1 and point 2, this is my x value for point 1. So I'm going to call that x sub 1. This is my y value for point 1. So I'm going to call that y sub 1. This is point 2 over here. This is my x value for point 2. So I'm going to call that x sub 2. And this is my y value for point 2, so I'm going to call this y sub 2. Now all we got to do is plug in, all right? Y sub 1, I'm looking over here. I want to plug in y sub 1. Y sub 1 I said was 4. Minus y sub 2. Y sub 2 over here I said was 3. X sub 1. I want to plug in. I said was 2. Minus x sub 2, which is 5. Doing some leaf change switches because there's going to be a lot of negatives involved here sometimes. I'm going to go ahead and now 4 plus negative 3 is positive 1. This is where taking the sign of the larger number, really being aware of your positives and negatives is super important. 2 plus negative 5, negative 3. So I have negative 1/3. Double checking. We went all the way back to what we wrote at the beginning. This slope was supposed to be negative. And we got a negative slope. That's a quick check. Okay, that's going to save ourselves from some of the mistakes. Yes, ma'am.
The 2 4s and the 5, are those the points that you put in
Say that one more time.
The two down, are they on the graph? Did you like put the points on the graph or did the rise and run?
So the rise and the run are these subtractions, and these points were given to us on the graph. All right, so next one, same thing. We're thinking about our equation here. Slope is equal to rise over run. Okay, if slope is equal to rise over run, rise is my change in y, which is my y1 minus my y2, over my x1 minus my x2. So I'm actually going to label these backwards of what you would probably think, and we're going to see if it still turns out okay. This is I'm going to label this one as 0.1, and this one is 0.2. Yes, Denzel?
So are we going to be writing y1 minus y2 over x1 minus x2 on?
Yes.
Okay.
That's going to also kind of help you with the memorizing process. So now I'm going to go through and I'm going to label those specific parts of those points. This is 0.1 over here. This is my x for 0.1. I'm going to call it x sub 1. This is my y for 0.1, so I'm going to call it y sub 1. I've labeled this one as 0.2. I'm going to call this x sub 2, and it's y sub 2. Now all I have to do is plug in. Really quickly, before I start plugging in, I know the value that I should get for this slope should be positive or negative. Where is this line headed? Down, down, down. This should be negative. All right, so y1. Where did I label something y1? That's over here. 1 minus y2. That's what I labeled over here was y2. And I need x1 minus x2. So x1, 4 minus x2 is 2. Yes, Joshua?
So I have a question.
Yes.
So, since you switched the names, could the answer also be, let's say the one you named 0.2, could that be number 1, and then you could do like, you would get a different answer?
So Joshua is asking, hey, I see that you switched around the names of 0.1 and 0.2. Are you going to get a different answer? I've already told you the answer is no. What I'm going to do is in a second, I'm going to go ahead and prove that to you by erasing this work and then doing it the other way. All right? So I've got 1 plus negative 2. That's going to give me a negative 1 over a 4 plus a negative 2, which is going to give me a 2. I got a negatively sloped line. Sure enough, this should be a negative slope. Yes, ma'am.
We were doing ones so like there weren't arrows, like one to each one. Would we still label it like point and stuff?
Yeah, we'll talk about that when we see a problem like that. But yeah, that's a good question. All right, so I'm going to go ahead and I'm going to erase this. And remember, we got negative 1/2. And I'm going to now label this the other way around. This was 0.1, and this is 0.2. This is the opposite of the way that we did it in class. That would make this x1 and y1, x2 and y2. So I'm going to plug into my equation. y1 is 2 minus y1 is 1. x1 is 2 minus x2 is 4. Leave, change, switch, leave, change, switch. I'm going to get positive 1 over negative 2. Is that the same thing?
Yes.
Kip yes or Kip no. Is that the same thing? I need you engaged here. Why is it not the same thing, Jaime? Yeah, it is the same thing. The only difference that you could perceptively see is that on the first way we did it, the negative was on top. Second way we did it, the negative was on bottom. But either way, if there's only one negative, it's still a bad day. So it's still a negative slope. Either way works fine. It doesn't matter which point you label as your point 1 and which one you label as your point 2. We've just proved that. Imani, did you still have a question?
No, just that with that negative one.
Yeah, same thing. Each is a bad date, right? If we made them both a decimal, we'd both call that decimal negative 0.5. Denzel.
Do we ever have to simplify?
If you get something that is not a simplified answer or not a simplified fraction, yes, you would need to simplify. All right. Oh, hey, look at that question right there. Does it matter which is point 1 and which one is point 2? Everybody, show me with your hands. Does it matter? No. All right. Both coordinates from point 1 must be, and we're going to talk about this thinking about our equation over here. Both of my coordinates from point 1 are here, and both of my coordinates from point 2 are here. So when we think about our equation, they should be on top of each other. So both coordinates from point 1, from one point must be, we'll just say on the left. And the coordinates from the other point must be on the right. So the biggest mistake that I see in these problems is flip-flopping your x's and your y's. Y's always go on top because that's your rise. X always goes on the bottom because that's your run, all right? All right, we're going to look at 2 more examples, at least 1 more. All right, so I'm looking at these 2 points. These 2 points are actually graphed for us. Okay, we are going to see problems where they're not graphed for us. What I want to go ahead and do, they haven't put a line through these 2 points. So they're saying, hey, what's the slope of the line through these 2 points? So we're just going to go ahead and we're going to put a line through these 2 points. Putting a line through those 2 points is going to make it very obvious that the slope of the line through these 2 points is positive or negative, question mark. Negative, because it's headed down, down, down. Since we don't have a coordinate grid to make our slope triangles, we're going to go ahead and write out our equation. Slope equals rise over run. Which we know the rise is our change in y, so that's y1 minus y2 over x1 minus x2, the change in our run. So now I'm going to go ahead and I'm going to label these points. I'm going to call this one point 1, and I'm going to call this one point 2. So as part of your work, yes, I want you to label them. Then I'm going to label my parts. So if this is point 1 over here, the 1 is the x for point 1, so I'm going to call it x sub 1. The 2 is the y for it. I'm going to call it y sub 1. This is point 2, so I'm going to call this x sub 2 and y sub 2. Now I'm just going to plug in what I've got. Y sub 1, that's right here, that's 2. Minus y sub 2, that's right here, 1. X sub 1, that's 1. Minus x sub 2, that's 2. Leave change switch, leave change switch. 2 plus negative 1 is 1. Over 1 plus negative 2 is negative 1. This is one, like Denzel was asking about, we do need to simplify here because this is going to be a whole number 1 divided by negative 1 is negative 1. So we get negative 1 here. We want to quickly check back. Hey, was this a negatively sloped line? Yes, we wrote this down earlier. We should get a negative slope. All right, I'm going to do one more. I'm just going to do it pretty quickly. Put my line through. I hear RJ saying positive, because he sees this line is going up, up, up. Slope is equal to rise over run, which is my change in y, y1 minus y2, over my change in x, x1 minus x2. I'm going to label this one as 0.1. I'm going to label this one as 0.2. So this is x1, y1, and x2, y2. I'm going to be plugging into my equation. So I've got y sub 1, that's this negative 2, minus y sub 2 is 5. And x1 here is negative 2 minus x2, which is 1. Leave, change, switch. Leave, change, switch. Negative 2 plus negative 5 is negative 7. Over negative 2 plus negative 1 is negative 3. Now, the fraction here can't be simplified, but there is one thing that we can do to simplify this. Nehemiah? Yeah, we have a negative over a negative, so we know that's a good date. That's going to make it positive. And that's going to help us go back and say, hey, yes, indeed, this was supposed to be a positively sloped line, and we got a positive slope. Awesome. All right, key points. Matthew.
Always label all label your points and
Yep. So, as one of the steps, label the points and sorry, I was trying to get the right there. You know, you got it there, there, and there, right? There, that's the possessive form of there, parts. And I'm just going to put in parentheses so we know what that means. x1, comma, y1, and x2, comma, y2. Those are the things that we need to label. Second key point, I'm going to save you the time. Obviously, this equation and the understanding of how to create this equation for ourselves, this is going to be super important. Okay, questions?